All right, welcome back, guys. Good to see you again. We're getting to 13.4, kind of winding down. Only 3 more sections to go. Today we're going to talk a little bit about how to use those trig functions to find angle measures. And what it involves is the inverse is what we're going to look at. And you can kind of see that when you talk about an inverse is we're going to see that -1. That doesn't mean it's raised to the -1 power. Really, it's a flip, right? We're gonna look at the inverse of it is what we're looking for. So anytime we're finding a missing angle, we're gonna have to do that. And the way to activate that, if you look over on the calculator, you're gonna have to hit second and then sign to get the inverse sign. So anytime you're finding a missing angle, you're gonna have to hit that second sign, second cosine, or second tangent in order to do that. Okay, so now again, we can also use the unit circle. Get familiar with that. Again, that'll be big as we move on to pre-calc next year, is kind of getting ourselves more familiar with that. But what you'll kind of notice here is that, remember that the cosine is the x value and the sine is the y value. So you can use those to kind of figure out where those angles are, as well as the calculator as well. But one of the things I just want to show you visually with the unit circle is that if we're trying to find the inverse cosine of √3/2, we're saying what angle measure provides us a y value of √3/2. Well, we can see it happens a couple spots in the x value here. It happens here at pi/6 or 11 pi/6, and that's in radian mode, of course. That would be 30 degrees and 330 degrees if we're in that mode. But we're also trying to get more used to the radian kind of idea too. We'll use that a lot more as we move forward, but be familiar with both. Now, here's the deal. Now, we talked about those coterminal angles. Well, so if we're trying to find all possible values, well, we know pi/6 is one of those. Well, I remember every time that we go around another revolution, we're going to get 2 pi. So we're going to say it's pi/6 plus 2 pi n. That's the number of times that we're going around in a circle, and that could be negative or positive, obviously, as we do that. Well, there's another spot too here at 11 pi/6, and then every rotation of 2 pi radians after that also works. So when we write those down, that's kind of the notation that you'll see. All right, let's try that again. Let's try another one here. What about the inverse tangent? That's kind of a tricky one because you got to figure out where is the inverse tangent negative or +1. Well, it's when you take y divided by x and get 1. So that's basically when y and x are the same thing. And again, you could just type this in the calculator here. That's kind of a nice thing. So if we went second, and then we hit the tangent, so you see how that works there. And then if we just put a 1, close the parenthesis, there we go. It's going to tell you 45 degrees, which is pi/4 radians. And then, of course, we can find it over here. So using that unit circle, that might be helpful as you find those as well. So once again, writing down all possible values, we'd say pi/4 plus 2 pi n. And then 5 pi/4 plus 2 pi n should be right there. We missed that. Now, if you're doing it in degrees, we would say 45 degrees plus 360 n, remember, because every time we go around, that's 360 degrees. So we can write it in a couple different ways. All right, now because there's more than one value of an angle of theta that produces the same output, we kind of put restrictions on so we kind of know where we're going. And these are actually programmed into your calculator. Is sine, we're always going to be in the first and fourth quadrants. So we're going to be from negative pi/2 to positive pi/2, or in other words, negative 90 to positive 90, because that shows you all the different values that you could get, positive or negative. Now, the cosine, remember, is positive in the first and negative in the second. So we're going to use those two quadrants there. And then tangent, we're going to use the first and fourth quadrants. So that's what's going to default come up when you type that in. And we know there's infinitely many in other spots that it could be, but those are the outputs that we're going to get with that. So keep that in mind when you do those. Okay? All right, so remember, so when we use that capital letter, that means we're intended to be in those domain ranges. If it's a lowercase, there's obviously infinitely many answers. But when we're talking about the capital letter, we need to be in those restricted areas. Okay, so once again, another little chart here as we do this, you can kind of see that, again, it talks about where we're going to be at. Okay, what are the numbers going to be, where we're going to be at in those things. And again, if you type it in the calculator's programmed for that, so you'll know that that is certainly the case. Okay, other names, they'll call them the arc sine, arc cosine, arc tangent. It's really just the same thing as doing inverse sine, cosine, and tangent. All right. So here we go. Let's find the inverse cosine of -1. Now remember, since that's a capital C, We're talking about the number that's the angle that's going to be in the first or second quadrant. Well, where it's negative root 3 over 2, if you look at your unit circle, you're going to find and look over here, okay, there it is. Yeah, and again, we're going to find that in the third quadrant as well, but again, because it's capitalized, we're saying we want it to be in the first or second for cosine, and there it is right there. Again, if you wanted to type this into the calculator, you could hit second cosine, and let's see, then we'd have to go negative. Let's do the square root here. Square root of 3. All right, click out of there, and then we're going to divide that by 2. And there we go. We got that. It should come up and say 150, and it does. And then you just have to convert that to radians as well. So using that unit circle that we have, that's kind of a helpful little chart for you to use. Go back to that chart. It's a good thing to have out. Even if you forget where it's at, you can always just Google unit circle and you're in. Now here's another thing that we got to make sure of is that we're going to hit mode here. And make sure, your calculator is in degree mode. Okay, you can put it in radians or degrees. Make sure it's in degree for our purposes here. If it's not, change it. You should be all right. So that's kind of a good thing to have there. All right, otherwise you're getting all the answers wrong, aren't you? All right, how about this? Evaluate your inverse trig function and give it in both radians degrees. So we're looking at the inverse sine of 3/2. So we're looking at what degree gives a y value of 3 over 2. And I think you're going to find a problem here. Right? Because if we go inverse sine and we go 3 divided by 2, all right, we got a little fly in the ointment here, don't we? It's going to say error. Well, that's that sine. Remember, sine has to be in between -1 and 1. That value does not exist, and you won't find it. So we'd have to say none. There is nothing that gives us that as we go. So again, a little tricky one there. Got to be careful. Know what happens on the calculator when that happens. All right, here's another one here. Where is the inverse sine? Negative root 2 over 2. Now remember, sine is in the first quadrant or the fourth because it's capitalized here. So we're going to look at where is the y value, negative root 2 over 2. We do find it down here at negative 45 degrees. Don't say 315 because we're between negative 90 and positive 90. You want to use it as that or negative pi over 4. Be real specific on those. All right, here's another one. Where is the inverse cosine 0? So where is the x value 0? Well, right smack dab. You can see it on the unit circle right there. It's at pi over 2 or 90 degrees as we go there. All right, so let's put that into some application here. Here's a little problem that we'd have. You'd sit here, a group of hikers wants to walk from a lake. All right, so we're going to walk 1 mile east and 0.75 miles north. And so we want to find, well, what's the angle? What's that angle in the nearest degree? What direction should they go? Instead of doing that, they can take the shortcut, right? Find that hypotenuse. Well, here's the angle we want. We know the opposite and the adjacent side. So we're going to find the tangent. So second tangent, and we're going to go opposite, which is 0.75. And we're going to divide that by the adjacent, which is 1. Really didn't have to do that, but it's there. All right, we get that. Well, there's our angle measure. Again, to the nearest degree, we would just round that up to 37 degrees. Always look and see if they want to the nearest tenth or nearest degree, whatever they want. We should be able to fit that in. So again, good easy way to find the angle. Now, we've done stuff like that before with right triangle, trigonometry. A lot of times we're using find a side. Well, now we can find the angle. And again, so just always look at your SOHCAHTOA, look at the sides that you know, and that should tell you which trig function to use. But remember, anytime we find the missing angle, we got to use the inverse, sine, cosine, or tangent. All right, here's some other interesting things here. Solve each equation to the nearest tenth. Now, this is where we do want to use the calculator. And we want it to be between negative 90 and 90, which is fine because that's exactly where sine is going to be found here. So we're going to find inverse sine of 0.4. Want to find that angle, go ahead and hit enter. 23.5, so the nearest tenth, I'd go 23.6 degrees. And since we're in that range of negative 90 to 90, well, yeah, we're set. Now, how does the problem change? Well, problem changes here if we put the restriction, well, what if we want it to be between 90 and 270? Well, if I put this in the calculator again, I'm always going to get 23.6. Well, if I need to be between 90 and 270, I got to figure out, well, where is the sign positive? Well, it's positive in the second, negative in the third quadrant. So we have to use that as a reference angle. So remember, reference angle, we got to take that 23.6 and we have to figure out that's the reference angle here. So that technically is the angle 156.4 because that's the angle we get here. This angle is just going to be that reference angle, that angle that gets you back to the x-axis as quickly as you can. So again, you're just using that as a reference angle to fit you in that restriction that we have there. So be careful about what it's asking. Let's try another one of those. Let's do the inverse tangent in between of -2, and we're going to do it into something that's in the fourth or first quadrant, which naturally it is going to be. So that's the answer we're going to get here. Second tangent of -2, and we get that. Okay, so negative 63.4 degrees. Okay, and that fits in our restriction of between -90 and 90. That's good. All right, well now the problem is that, well, what if we change that restriction? We're still going to find that angle, but what if we want it to be between 90 and 180? Okay, so we've got to figure out, where is the tangent? Where is it negative? Is it in the second or the third quadrant? Well, remember, tangent's going to be negative in that second quadrant, so what we have to do is we have to take that and subtract that from 180. Just take our answer, let's just go plus 180. And that gets us that angle. We've got to have that angle that's between 90 and 270, because that's where the tangent is negative. I'm sorry, 90 and 180. I'm sorry, that is the second quadrant. What was I talking about? So again, we're looking at 116.6. 116.6 falls within that range. So again, if you wanted it to be in the third quadrant, you would add that to 180. And if you wanted it to be in the fourth quadrant, you could always just subtract it. You know, if it was from 270 to 360, you'd have to subtract it from 360. So you got to use those reference angles is what you got to use there. Okay. All right. Well, that takes care of inverse functions. Practice those on 13.4. And until next time, I'm Mr. Boone.